Great seeing you here. My name is Luc de Koster, founder of the Koster Academy, and in this video I will talk about the principles and the idea of the critical path method. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the critical path method. What is the critical path method? Now, the critical path method, also abbreviated CPM, was originally improved or developed to improve the efficiency in the production environment. And it was looking into the principles of cost reduction. Cost reduction is very important in an operations environment, and the critical path method was a way to deal with the increasing costs, reducing costs, and increasing production or operations efficiency. Now, when we look at the critical path method, we have the following steps that are typically completed one after the other. First of all, we have to define or determine all the activities that have to be completed in order to finish the project or the work that you want to do. Typically, we do this using the WBS, and we get a series of activities. When we call it in PMI, we call them work packages, and those work packages can be further decomposed into activities so that we can plan them normally. Work packages may be too large to plan them in detail, so we have to decompose those work packages in smaller activities. Once we know the activities, we can estimate their duration. There are different durations methods we've been talking about before. Estimating the duration is very important because it will help us to identify the start and finish time of the different activities. Then we have to create a project schedule. We have different methods we've been discussing before. We look at two families, basically activity on the arrow and activity on the node. And we have the scheduling techniques or methods, the arrow diagramming method, the program evaluation and review technique, or the precedence diagramming method. One of the elements we have to do here is to order or organize the activities in a way that we understand what activities have to be completed before a specific activity can start. We call this precedence determination. We find the precedence of those different activities. Once we created the schedule, we can calculate the early start, early finish, late start, late finish, also the slack of all the activities, and we can determine or identify what we call the critical path. The critical path is the longest path through the network, and we have to be careful here because when people do these calculations, typically they say the critical path is the path where the slack is equal to 0. This can be the case in certain specific examples, but it's not necessarily true. Whatever we have to find the longest path through the network. There is always one critical path, and there also may be more than one critical path. Basically, all critical paths could, in the worst case, be critical. Now, once we have this, we focus on planning, scheduling, and controlling the critical activities. Basically, we're going to focus on those activities which are on the critical path. And when we have a problem with an activity on the critical path, it has immediately an impact on the duration of the project. If the activity is shorter, the project duration will be shorter, but we can have the appearance of another critical path. When the activities on the critical path are longer, we will see that the project duration will increase. Then we add milestones and the deliverables on the planning, and basically these are the steps of what is typically known as the critical path method. We're doing this when we're planning the project. We're doing all these steps in a natural way. We also have the two arrow diagramming methods and the precedence diagramming method. We have two possibilities to, let's say, schedule the activities. And originally, the critical path method was developed using the arrow diagramming method, but we can also use it with the precedence diagramming method. There is no difference, there is no need to use the ADM or the PDM when we are in fact scheduling the activities. The networks may look different, like we will see in some exercises, but the final results, the outcomes, the start and the finish time, the schedule using either one of these methods is identical or should be identical. Now in the ADM, this is a little bit more tricky to use the arrow diagramming method. Here we use arrows as indication of the activity. The activity has a start node and a finish node, a tail and a head node, and it's in fact the activity is occurring between those 2 points in time. So the tail event is the start of the activity, which is also the start milestone, and the head event is the end point of the activity, which is also the end milestone. This is an event-based method, and we look at the start and the finish time at the activities. We look at the events, the points in time, and we start the calculation from the point 0. We're using cardinal numbers to do the calculations. The precedence diagramming methods seem to have been developed around the same time. Now here we don't use the same method to represent the activities. We don't use the arrows, but we use a node, and the node contains all the information about the activity. We will see later how this node typically looks like. Now, the arrows show the relationships between the activities, between the nodes. And here we have 2 possibilities to start the calculations. We can either start from 0, so we use the start event and the end event of the activities, or we start from 1, and then we're using the ordinal numbers like the dates, the start time, let's say 9 a.m. in the morning, and the activity ends at 5 p.m. in the evening. So it's a little bit a different approach, and typically when we use the dates, we start from 1. There is also the Pert method, the program evaluation and review technique, is a similar method to determine the sequence of activities and the critical activities or the critical path. Now, it was developed by the Department of Defense in the United States as part of the Polaris project, and when we looked at this critical path method, we looked at typically the durations that were fixed because we were talking about production information. The durations in the Pert method are variable, and each activity has an average duration or expected duration with 50% probability and a standard deviation. So the Pert uses the same type of diagram like the arrow diagramming method, but the durations are variable. Now, the result of the Pert diagram is an expected duration of the project and a standard deviation providing information related to the expected duration and probability of the project, so we can find a relationship between duration and probability to complete the project within a certain time frame. So that was it for this short presentation, short video about the principles of critical path method. Let's have a look at the next videos, but before leaving, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you, and I'm looking forward to seeing you in our next videos. Bye bye.